Hey everyone, and welcome back. So today we are going to solve one more problem from Leetcode, which is also easy problem, but the algorithm we are going to use in this is important and directly related to this type of questions. Okay, so before moving to the algorithm, let's first see what is our question. So you have given an array of nums. Okay, now you have to return a number which is available more than n by 2 times. Means if we have size of array is 3, right? If you divide by 2, it will be 1.5, which is 1. So which number is greater than n by 2? It is 3. So our answer will be 3, right? Let's take another example. So let's say we have 2, 2, 1 1 1 2 2. So our array size is 1 2 3 4 5 6 7. 7 divided by 2, 3.5 equivalent to 3. So which number is greater than the 3? So we have 1 2 3 4. It is greater than the 3. 1 2 3. Is it greater than the 3? No. So our answer will be 2. So you just have to return a number which is greater than n by 2, and n is our size of array. So for this we are first going to use map. You have to only count the numbers and the count should be greater than n by 2. So in this example we have 1 and 2 only, but there may be other examples where you have multiple numbers, so you cannot keep track of every number. So for this we will use our map data structure. Okay, it stores data into key value pair. So key will be our number and the value will be count of that number. Similarly for the 1, so map will store data in this way. I already taught you how to use map. You can see previous videos. There is a data structure map. So it stores data in a key value pair, and every value is storing frequency, or we can say count of that number. After storing these number, we can easily compare it is greater than n by 2 or not. If it is greater than n by 2, we can return our answer, right? So let's write a code for this. So let's first declare map int mp. So that's how we declared a map, and these int means we are storing two data, which is key and value. Both of them are integer. Okay, then we will run a loop in our array int n equals to nums dot size. Okay, this is our nums, and we will run a loop. Now we will add the key value into the map. So this num will become key and this plus plus will become value at that key, right? So if you look at it, initially you have this empty map. You are at this index or this value, so 2 will be inserted as a key and the plus plus will increment your count here. Then if you move to the next index, 2 is already available, so it will find 2 using that key and will increase your count by 2 because it is doing plus plus, means it is incrementing your number. Now let's move to the next. If you are at 1, then 1 is not available in the map, so it will insert 1 and increment its count. Then let's move to the next one. Then again 1 is already available, so it will increment count here. Then again 1, so it will increment your count again. Then we are at 2 is already available, so it will increment your count directly here. Then again 2, so it will increment your count here. So basically it is incrementing your count. So finding the value with the key and plus plus is incrementing the count for that value. So in this way we were able to create our map. Now we just have to check the majority element. So for that we will run another loop into the map and we will check if it dot second is greater than n by 2. If it is, then we can return our value, right? This is our range based loop. This is also a way to write a loop in the standard template libraries. So the value at the second in the map is a frequency, so we are comparing frequency with the n by 2. If it is greater than n by 2, we will return its value which is available at the first position. Okay, in this way we will get our solution. Now let's talk about the time and space complexity. So our time complexity will be, here it is running for the n times. here also it is running for the n times, so it will be n plus n, which is 2n. okay, space complexity will be big of n because we are using map to store the data. In this case we have 2 and 1 only, but if all the numbers in the array were unique, then the map will be storing all the unique numbers, so it will be storing all the n number of elements or values. So it will take n in the worst case. In the best case it will only store one element, so we can say it can be 1 in the best case, but we talk about the worst case, so it will be n. So this is our time complexity and space complexity. Okay, one more thing, we missed this time complexity, which will take log n. By log n, because every time we are inserting a value, it is trying to find a value in the map, so it is finding if it is already available or not. So to check that, it takes log n time complexity. So here our time complexity will become n log n. So overall time complexity will be n log n, right? Because n log n is greater than n, so we can remove the n time complexity and our time complexity will become n log n. So first let's write this code, then we will move to the optimized solution. So this is our problem. Majority element is the element that appears more than n by 2 times. Okay, in this example 3 is the element which is greater than n by 2, and in this example 2 is the element which is greater than n by 2. So let's first declare our size of array, then let's declare a map, then we will run our loop and we will insert our key and value into the map. Okay, so at every key we are incrementing the value. After that we will run another loop, auto it mp. So in this case we are not iterating over the index, we are directly iterating over the values itself. So we will check for the second value, if it is greater than n by 2 we can return its first value. Okay, because first containing the element and the second containing the count of that element. So here we are returning a function, so maybe we will be able to get our answer here, but in some cases we are not able to get our answer. So here by default we return 0. Now let's run it. So let's submit it. So it got accepted without any problem. Okay, so in this case we used a map data structure to count the frequency of the element. Now let's look at it. There is a follow-up. Could you solve the problem in linear time and the big of one space? Okay, so here our time complexity is n log n and the linear time complexity is big of n. So it is asking us to solve the problem in the big of n and the space complexity should be big of 1. So it does not want to use map or any other data structure to solve this problem. So for this there is an algorithm which is more a voting algorithm. Okay, so let's see how this algorithm works. So we have this array and we will declare two variables, count and num. Count will be storing the count of a number, means frequency of a number, and num will be storing our current number. So initially we are at this. So initially our count was 0 and num was 0. So when we are at the first position, our counts become 1 because 1 we got first time, and our nums become 2 because this is our current number. Then we move to the next value. Now 2 comes again, then our count will become 2, right? Because 2 we have already seen and our num will still be 2, right? Now let's move to the next value. Now this time we have different number. Okay, so we will reduce our count because it is a different number, so we will reduce our count and our num still be 2. Okay, so basically num is the one which is storing majority element. So till now, according to the count, our 2 is still the majority element, so num still be 2. Now let's move to the next value. Now 1 comes again, right? So our count will decrease again and our num still be 2. Let's move to the next element. Now 1 comes again, so and our count becomes 0. We have 1 here and count is 0. So that means the majority elements of 2 is not possible till now. From here to here, majority elements of 2 is not available. So we will replace our num with the 1 and count will increase by 1. Okay, now let's move our, now 2 comes, it is different than 1, so count will decrease again and our num still be 1. Now let's move to the next element. Now we have again here 0, that means the possibility of majority elements from the 1 is not possible, right? So we will update our num with the 2 and the count will become 1. So at the end, the element which remains is the majority element. So basically we are going one by one from left to right and we are taking a vote from every number. So 2 given, 1 vote, another 2 given, another vote which counts to 2, then 1 comes, 1 reduce the vote from others, then this one reduce the vote from previous ones, so all the votes become 0, so the majority will become 1, right? 1 again becomes 0, then 2 becomes again with the majority element. So you can think of as a way that you are going one place to another place, and if same people's voting for a same person, then you will be increasing the count, and if different person voting for the different person, the count of that previous person will decrease. Okay, so here we are using only one voting system and we are incrementing and decrementing in a single element. So even we are getting 2 as a majority element, we have to cross check that element is really the majority element. Okay, let's take another example. We have something like this. Okay, we have count initially 0, num initially 0, we are at this position, our count will become 1, num will become 1, right? We move to the next, so this 2 will decrease the count from the previous, so it will become 0 and our num still be 1. Then move to the next, our count is 0, so it will increment by this new number and our num will update it with the 3. Then we will move to the next, then it will again decrease our count, then we will move to the next, our count is 0, so we will update with the new number, then we will move to the next, it again becomes 0, then we will move to the next, then it will become 1 and our num will become 2. So if you count the 2, 1 2 3 and 4 is greater than 1 2 3 4 5 6 7 by 2, right, which is 3. So 2 is our majority element. So whenever we are getting a 0, we will be updating the new number and the count. So let's write the code for this. So we first declare num equals to 0 and count equals to 0, and we will run a loop I less than n, I plus plus. Okay, and we check if our count is 0. If our count is 0, then we will be updating our num with the new number and will be increasing our count plus plus, right? Here we are doing this, our count is 0, right? If our count 0, then we will update our num with the current number and count plus plus. So that's what's happening in this first if condition. Else if our nums I equals to num means this number and this number are same, then we will increase our count, right? Because we already have 2 here and currently we are also getting 2, that means both of them are same. If both of them are same, we will increase our count. So if both the numbers are same, we will increase our count, else we will decrease our count, right? If the number is different, we will just decrease our count and the num will remain same. So this is our code, and the time complexity is big of n because we are running only one loop, and space complexity is 1 because we are not using anything. Okay, so let's write the code. So let's remove this and this. Let's declare our num equals to 0, int count equals to 0. Then here we will write our condition. If our count is equal to 0, then we will update our num with the current element and will increase our count. Else if our current num is equal to the current element, then we will just simply increase our count. Else our third case will be different element, so we will decrease our count. So now what I was saying that even you got a majority element, you still have to check if it is really a majority element or not, right? In some cases this algorithm may fail, so for this we will write another loop and we will check if the num equals to nums of I, then we will increase our count plus plus. Okay, so we will reset our count here again and we are using same variable, so I reassign the count 0, and in the num I have majority element, and the nums of I have element from the array. So I am comparing. If it is equal, then we will increase our count, and I will check count greater than n by 2, then we can return our num here, or we can return 0, which is default. Okay, so for this algorithm we have to write this extra check loop to check if that majority element is correct or not. So let's run it. Okay, return 2 times. So here you can see the code is working, right? The time complexity will still be big of n if you remove the constant, or it will be 2n, right? And for this, so it will become 2n, but the constant term will be removed, so it will be n itself. So it is still a linear time complexity. So this is our code. So we are kind of giving a boat to every element. If at some point our boat becomes 0, then we will update with the new number, and our boat is same with the current number, we count increase, else we will decrease the boat. And here we are checking if that element is really a majority element or not. If it is, then we can return, else return 0. Okay, so in the next video we are going to solve another version of that problem, which is majority element 2. Okay, which is using same concept. So in the next video we will solve that problem. That's it for today. Until then, thank you everyone, have a nice day.